I welcome you back. So we are still on multivariant. The joint distribution. Distribution. Another example. What does it say? So the example says that suppose that a point xy is chosen. Suppose that a point xy is chosen at random from the region S in the xy plane, containing all points xy such that x is non-negative, y is non-negative, and 4y plus x. 4y plus x is less or equal to 4. So a point, that point is not known. Suppose a point is not known. You see, it is in terms of x and y. It is an arbitrary point. You are in the Cartesian plane. Akati? Ntiolina okusindika. Kata. So a point is arbitrary. It is chosen at random from region S in the XY plane. So the region S is defined. The region defined in this form. So you see we have a line, and this can be sketched. Anyway, before I dissect the problem, let us what says. Part A, determine the joint probability. The joint probability density function of x and y. PDF. PDF of x and y. Then what else do they want? Part B. Where are you? Part B is here. Suppose suppose that S naught is a subset. Suppose that S naught is a subset of the region S. Yeah, on the subset of the region S subset of the region S having area A, comma, area S naught is a subset of region A having area A, comma, having area alpha, having area alpha, determine the probability of that. So part A, they want us to determine the joint. Now, this module, the challenging bit of this module, anyway, it's not challenging, but the dynamics of this module, it is combining probability theory and statistics 1. It is combining probability theory and statistics 1 plus calculus 3. How to integrate multivariate functions, double integrals, triple integrals. That's where we are operating. We are operating in that framework. So we want to determine the probability density function. The probability density function. But they have told us that suppose a point xy, suppose a point xy, is chosen at random from the region AC in the xy plane, and that region is defined by this. Maybe we can also visualize it. What is that region? It is this region here, the one which I'm highlighting in blue. The region is x greater or equal to 0, y greater or equal to 0, and 4y plus x less or equal to 4. Now this is the same as if I make y the subject, particularly for this last expression. This is y, 4y less or equal to negative x plus 4. And that is y less or equal to negative 1 over 4 x plus 1. So I have this. I also have x greater or equal to 0, y greater or equal to 0. Let us sketch. This is the y-axis, and this is the x-axis. The y-axis, I hope you agree with me that the y-axis is the same as the line x equals 0. So this is x equals 0. And the x-axis is the same as the line y equals 0. So this is y equals 0. So what do we have? We have x greater than 0. So maybe I start with this one. This is a line. I am referring to this. This is a line. No, it's a region. Sorry. It's a region, but to sketch that region, we start with y equals negative quarter x plus 4. This is a line with negative gradient. It's a line with negative gradient a quarter, and if x is 0, y is 1. If x is 0, y is 1, somewhere around there, and if y is 0, x is 4, somewhere around there. So this is my line. This is the line y equals negative quarter x plus 1. But less or equal to, it is a region below this. This is what they are referring. That region now. That region is y less or equal to. Then x greater than 0, x greater than 0, values of x that are greater than 0, there are these values. Then values of y that are above 0. What have I shaded? I have to be careful. This is, sorry, this shading is for what? For values of x, yeah, x above 0. Yeah, x above 0. All values of x that are above 0. That side. Then all values of y that are above 0, values of y that are above 0, all those values. Now look at the intersection of all those shadings. The intersection of all those shadings is this shading in red. That region is the intersection of all those shadings. And the question says that a point is chosen at random from that region. A point. That point can be here, can be there. It is a point which I don't know. A point which I don't know. So what am I going to say? I'm going to let my joint distribution f xy to be that point, say k, I don't know it. So it is a point k, but obtained from the region that starts from, now here we have to be careful. The region starts from, note that, what do I have? I have y. There are two cases. I have y greater or equal to 0. Hope we are together on that case. Y greater or equal to 0, but this y is still less or equal to negative quarter x plus 1. So I have that. So I have 0 less or equal to y less or equal to negative quarter x plus 1. Then I also have x greater or equal to 0. But there is also a version of x. There is also a version of x which we want to establish. First of all, x is greater than 0. Opt for this interval of y that has been well understood. Moreover, okay, that has been well understood. So I want to interpret also x. I have x. I want to obtain a range of x values. X values start from, they start from here. Look at this. They start from there. X starts from there and they end there. Here. And you know which point we are having here? The point, this is x equals 0. That is x equals 0. So we want to determine the x here. What is the x there? So to determine the x there, y should be a 0. Because on that line, y is a 0. So I'll have 0 equals negative quarter x plus a 1. So a quarter x equals a 1, meaning that x is a 4 for that case. So x starts from 0 and ends at a 4. 0 elsewhere. So this is the joint distribution. This is the joint distribution, but I have to remove the value of k. So we determine the value of k and we write our distribution very well. I mean the value of k, and we write our distribution very well. So to determine the value of k, we use the property that the double integral over all x, all y, f x y dx dy is a 1. The 1. So I'll have the integration from 0 to 4. Those are what? Limits for x. Then y starts from 0 to negative a quarter x plus 1. I am integrating k. I have started with limits of y, so this is dy dx, and this is equal to 1. So we integrate. K is a constant. So you see, y comes first. So I first integrate with respect to y. So integrating with respect to y, I get y times k. What are the limits? 0, negative a quarter x plus 1 dx. This is equal to 1. So where you have y, substitute those limits. You have the integral from 0 up to 4. K, substitute y, negative a quarter x plus 1, then minus a 0, plus 1 minus a 0, dx equals 1. Then I integrate with respect to k. I'll have the integral from 0 up to 4. K, oh, sorry, I am integrating. Integrate, we shall have k negative a quarter times x squared over 2, then plus x 0 to 4 equals 1. Substitute 4 and 0, substitute the limits, you have k into negative a quarter times 4 squared over 2 plus 4 minus, when I substitute a 0, I get a 0. This is equal to 1. So this implies that if I solve for k, it implies that simplifying that expression, some terms are going to cancel out. So up this 4 will go with a certain 4 up there. Then I'll remain with 1 4 up over 2 negative 2 plus 4 negative 2 plus 4. That is 2k. 2k equals 1 over 2 over 2, meaning that k is a half. K is a half. Then I write back my distribution. So my distribution, the required distribution is fxy is equal to k is a half. X was starting from 0 less than x less than 4. Then y we are having 0 less than y less than negative a quarter x plus 1, then 0 otherwise. That was for part A. Then for part B, suppose that S0 is a subset. Suppose that S0 is a subset of the region S. S0 is a subset of the region S. You remember a property which I defined? Maybe I take you back, because you people can easily forget which property. Hope it is here. Otherwise, if it is not here, it is not here. But I defined that property when I was introducing this continuous case, probability over a region. Look at the conditions that I defined for continuous. Look at those conditions which I defined for continuous. Now, from those conditions which I defined for continuous, let me see whether I have it here. This is the condition I'm referring to. It was property 3, part B. Now for part B, recall that we saw that from properties of this continuous, we saw that probability of x, y over a subset, this is the same as integrating. We are integrating over that subset f x y dx dy. That was the definition. Yeah. Therefore, here I want the subset. The subset of the region is S naught. The subset of the region is S naught. The subset of the region is S naught. Yeah. So therefore, from that property, we shall have substituting here. We shall have that the required probability of x, y to be in S naught. This is the same as the integration over S naught, the integration over S naught f x y dx dy x dy, and this is equal to the integration of S naught. What is fxy? The distribution is a half. Dx dy, but that is a constant. That is a constant. Therefore, this is the same as having a half times the area over that region, and the area times area over S naught. What is the area over S naught? It was provided as alpha. So the area was provided as alpha. So this is equal to a half alpha, as simple as that. So that marks the end of that exam. I think that I have to do one more example, and